Storm Prediction Center has outlined a level 3 out of 5 enhanced risks for a large portion of Illinois, as well as a level 2 out of 5 slight risk for other portions of the state. This is going to have all hazards at play. The main hazards are going to be tornadoes and large hail. Tornadoes may be up to EF2 intensity and possibly greater, and hail could get up to baseball size hail, being 2 inches in diameter or greater. Again, in this area of Hatch. As a reminder, the Storm Prediction Center has changed their graphics to an extent. In our case here, this hatch is going to say is outlining an area where hail, if it does form, could be greater than 2 inches in diameter, and this is basically showing where tornadoes could be EF2 intensity or more. So I'm going to be looking at the synoptics of this event, kind of the meteorology behind it, and what is going to be happening for tomorrow. I also do want to make a quick mention. There is a dual enhanced risk with this setup, but I'm going to be focusing more on our northern system here. We have a cutoff low going on down here, forming some, again, also hailstorms in the south, along some embedded tornado threats down there as well. But I wanted to focus specifically on our northern mode, because that's where basically where I live, and that's where the larger tornado risk is located. So for today, I'm going to be having to use Pivotal Weather. The College of DuPage site is down right now, so do bear with me with some different graphics than usual, but nothing should be too big of a difference. So the first thing is, right now, let me first check satellite. We basically have a cutoff low going on here, kind of off of around the Gulf of California here. There's western Mexico. You can see pretty clearly here. Here's our cutoff low, which is forming a lot of convection and basically rain showers over portions of Mexico, some regions in Texas. We have an ongoing MCS going on out here in Mississippi and Arkansas today, with also a slight risk of severe weather for today in that region, mostly due to wind and hail concerns out there. And then for the most part, we have fairly zonal flow across lots of the country here. We don't really see too many embedded shortwaves apart from maybe right here. And for the most part, flow is pretty zonal across a good portion of the country. You can see it right here. Here's our initialization right now. Fairly basically conditions right now. This is the 15Z wrap model. So this is going to be 10 a.m. Central Time today as I'm making this video. So a few hours later or older, but the idea remains the same. We have this cutoff low going on kind of near Mexico, which is going to slowly meander to the east here, eventually starting to join back with the main zonal flow. Maybe a little bit of a troughing beginning as some of this evens out a little bit here. For tomorrow, looking at 12Z, we have this cutoff low sitting here with the most of the belt and of enhanced flow rounding the base of it. That will be affecting Texas. For concerns in the Midwest, the main thing we're going to be paying attention to is going to be shortwave troughs, which we'll get to in just a moment. But with time here, again, you don't really notice too much of a shortwave going on. Possibly a little belt of enhanced flow here to aid in any convection with 500 millibars. Let's look at 200 millibars, excuse me. 300 might actually be more applicable. I'm hoping that this will load for me real quick. 200 millibars is much of the same. We have this general similar feature. The cutoff low is a little less well developed here, in this case, with a little more of the flow to the east of the trough axis there. But a similar idea here, right? If we go down to 700 millibars here, again, loading will take a little bit longer than usual, but that is okay. I'll move around with time. Watch with this 700 millibars. I do want you to keep an eye on the central plains out here, with time here. Let's move forward, and something you'll notice right here, 18Z, right? You have your initialization at 12Z. Notice this little bit of wind right here, a little bit of a little belt of enhanced flow, and a slight kink in the contour right there. You can also see this in a wind shift out ahead right here. So we have winds a little bit out of the southwest there, and here a little more out of the west. Again, those aren't exact barbs, but you can see there is some kind of wind shift here associated with this kink and this belt of a little bit more enhanced flow, likely a short wave working through right there. Move forward with time. This continues to propagate to the east, eventually overspreading regions in Illinois, kind of where we're expecting severe weather tomorrow, basically being this little region in kind of Peoria and Bloomington being the center of that risk. Region Kankakee as well. Again, a very large area is under the gun for severe weather tomorrow. I think population-wise, this is over 10 million people are in those enhanced risks. Tornadoes specifically in that 10% tornado risk. That's 1.6 million people there in kind of Illinois over regions there. Looking at 700 millibars though, And moving forward with time, you can see that shortwave does work its way through. You can see possibly a leading one here and a secondary one back here. But either way, this belt of enhanced flow is going to help lead to some more forcing. Now, what I want to do now is get closer to the surface. So let me zoom my sector into the Midwest. And I'm going to get down to the surface map now. We're looking at our temperature and wind barbs for right now. We'll watch this as the surface pattern moves on with time. Unlike many setups, we don't have a large 500 millibar low that's really forcing our surface low to move with time. We don't really have as much of a distinct surface low with this event. Our main forcing for a surface low is going to be with that shortwave trough we saw. So here we are, we're going into the overnight hours of Tuesday. Here is 7 a.m. on Tuesday. Some of these warmer temperatures creeping up. Again, I do want to mention that compared to my usual imagery from College of DuPage, you have these deeper colors are not as intense as they will be on College of DuPage. College of DuPage, red colors typically are in the 80s to mid to high 70s. Here on Pivotal Weather, these are more in the kind of mid 60s right now. So you'll see what looks like very hot temperatures, which for March they are, but they aren't as hot as you'll see on College of DuPage. Moving forward with time here, again, here's our 15Z. We don't really have a very well-defined surface low. If I had to place it anywhere, it'd be right about here. You can see we have our wind shifting here, right? Winds out of the southeast, then curving here, possibly a little bit of a warm front here as well, with a trailing cold front on its way on the back end of this here. A little bit of it's a weird surface low that isn't very circular in nature. I do want to mention is this does move to the east with time. Here's 18Z. And one thing I want to keep in mind here is going to be what looks like an actual warm front in regions here in Illinois. Looking north of this front, again, you can mention we do have this colder air up here in the north of the state, kind of moderate warmth here, and then even warmer temperatures here. 75 over here, 65 here, and then 40, 43, 45 out, kind of near Chicagoland there. The confusing thing about this setup is this is actually a secondary, kind of a secondary warm front. So we have a low going on way up here in Canada, which is basically producing a stalled out cold front. This is partially lake breeze. That's the wrong color. Excuse me. Oops. That was the wrong color. This is partially a lake breeze, partially a stalled out, kind of stationary cold front, which is able to go way back into the low in Canada, kind of off of the map here. But what I want to really mention then is warm front is going to actually be draped right here. Knowing that temperature boundary, again, you do have that 70s, kind of mid 70s here and mid 60s here. This is going to lead to an area of lifting, and noting also the surface winds out ahead of the warm front, so basically north of the warm front, more southerly. That's a bad factor I just drew, but for the most part, a little bit more southerly, whereas behind the cold front, these are going to be a little bit more southwest. Again, a little bit idealized based on the surface vectors you can see here, but that is the same idea. Our main best winds are going to be a little bit ahead of the warm front, but our best temperatures and moisture is going to be back here. Let me now move to moisture, actually, because it is where we are now. Forward with time here again. Take a second to load in the dew points, but again, you can watch as the dew points come through. Partially, there's a broad, small thunderstorm risk today, general thunderstorms today in portions of Indiana. If we come back to tomorrow, again, you can see that warm front starts to drape here right about this time frame. Moisture overall doesn't have as much of a gradient, but with the temperature being higher, that means you have a little more instability with the regions with warmer temperatures and similar moisture rather than lower temperatures and similar moisture. So that is going to be basically what's developing our general area of interest. For me, that main area of interest then becomes where that warm front was located, basically right here in central Illinois, where you can use that warm front as an area of lift to help form thunderstorms, while also being in a good kinematic environment and a good thermodynamic environment. Basically, your storms are ingesting a lot of good, pretty good low-level moisture and low-level temperatures, warmer, and that will aid in storm development. What I want to look at now is going to be our lapse rates, which they do have lapse rates. Here we go. 700 millibars to 500 millibars. We're going to call this the mid-levels. Mid-level lapse rates are often a huge help in producing instability for thunderstorms. And you can see here this is not much of a question for Tuesday. Degrees Celsius per kilometer here. 7.4 is pretty strong for Illinois. most of the time we don't see too strong of mid-level lapse rates, especially not in March. Partially part of this is due to a EML that's going to be riding along the flow. An EML is an elevated mixed layer which occurs in the desert southwest, moves its way through the jet streams, and is basically a stable layer of air. I'm going to take a sounding right here in central Illinois where I'm most interested in. This is going to still be south of the warm front, I believe, so. But you can see those lapse rates here on the SKU-T. Pretty tight, or pretty strong strong instability. Well, not instability, but the temperatures decrease very quickly with height there. This is going to help to lead to more instability as the moist partial will cool at a slower rate, and that'll lead to a more buoyant partial. Corrected temperatures here are sitting at 76 degrees Fahrenheit. While the WRAP model does not currently have temperatures hitting there, models such as the National Blend, which basically shows all of the different high-resolution models combined, does show our temperatures reaching that point, meaning convection should be able to fire on its own. You can see the presence of the elevated mixed layer here, where you have this pretty dry air pretty rapidly, and a little bit of a capping inversion going on. This is most likely going to aid in hampering storms throughout much of the day. I'm going to move this sounding 3 hours later, where it will be used at 21Z. Again, that's 4 p.m. Central Time. And here we're starting to see more of that level of instability. Mentioning again the fact that our surface winds, or really our surface is not really warm enough yet. We're probably not really, the warm front is probably just about to occur, but you can still see that area of more elevated instability. That's going to be a big reason why we're going to be seeing hail and other nature of that. And also just the photograph here, pretty curved, kind of what you want to see if you're expecting a supercell thunderstorm with tornadoes involved as well. Let me move this forward just an hour. This should be right as the warm front has passed. Temperatures have increased. This could be a potential issue right here, this little capping inversion. But if temperatures are warmer, these parcels should be pretty buoyant. The last thing I want to look at before I look at simulated reflectivity from the HER models and other models is going to be mixed layer CAPE. So we're going to go look at our instability now. Apparently a new wrap run is available, but it's not going to be out far enough as I would like. Let's look at our instability here. Again, CAPE is basically storm fuel. How much fuel do these thunderstorms have? Mixed layer CAPE out here is pretty solid, about 1,500 joules per kilogram. There is some capping going on, as we saw in the photographs and the SKU-Ts. Sorry, the SKU-Ts specifically. We saw those that little bit of capping inversion that could have an impact on our event. But overall, we do have an area of broad instability, and if that warm front, if storms are able to ride up that little warm front that we had noted right about here at the time, those will be in an environment of pretty good instability. So now what I want to do is look at the HER model for some ideas of the reflectivities, how storms will develop. And this is actually going to be my first time seeing the HER, 18Z HER. I was waiting for that model to come through, and I haven't seen this quite yet. So we are going to do a basically live reaction to that. Here's 12Z, the day of. Notice, first of all, that we don't really have any thunderstorms to begin the day. It's pretty clear throughout the day. That's going to help lead to a lot of instability building in underneath the cap. And with time here, 18Z, that is 1 p.m. Now we're going to get 2 p.m. and 3 p.m. You can see some of those warm frontal showers there, indicating that presence of that warm front. Then you do start to get little blips up here in central Illinois. And these don't really develop until around 23Z. I do question what the HER is showing here, actually, because I do expect these storms to be in a pretty volatile environment. Something that has been pretty consistent throughout the cams with time has been a really explosive storm mode. The moment you start to see some of these blips showing up, these have blown up incredibly quickly, especially in this little region here in Illinois. Counties such as Will County, Kankakee County, I believe Grundy is out there as well. I may need to be a little better versed in my Illinois counties, but hey. But either way, these storms usually develop pretty quickly on all these different cams. We'll look at some of them as well. You can see eventually you do get a little bit of a hail-producing supercell located right about here. Let's take a little sounding of the HER, because I do have that ability on Pivotal. Yeah, the environment here, again, you're north of the warm front, so you do have a little bit of that cooler temperatures there. Shear is pretty good. Lots of SRH there. 400 meters squared per second squared of 0 to 1 SRH. That's a lot. That is a lot for a photograph. These are more elevated storms, you can tell here, because the more of the cape is elevated, it's above the ground. It's not really at the surface here. 3 cape is only 12 joules per kilogram, versus out in our kind of our open warm sector. Let me actually put this right behind basically a storm trying to fire back here at 22. This is what I'm most interested in. Here we have basically right after that warm front has passed, a lot better for storm development. Mixed layer cape, 2,600 joules per kilogram. That's, again, a lot of instability for, especially for March. 3 cape, that means your instability in those lower 3 kilometers of the atmosphere, 110 joules per kilogram. This photograph is very curved and very conducive for general supercell structure and lots of streamwise vorticity in the region, basically closest to the ground. Definitely a supercellular look here in this region in Illinois. And if storms are able to develop here behind the warm front, basically the warm front at this point is probably located right here. If a discrete cell is able to form here, it'll be pretty volatile and it'll be surface based, and that's what we're maybe paying attention to. Let's get to 7 p.m. here, and here is 8 p.m. where we get a large cluster of hail producing cells out here and kind of in the Quad Cities region, Western Illinois, Davenport, regions out there, Fulton and Clinton out there. Lots of hail producers out there very quickly. And with time, these do tend to kind of ride north of the warm front, even portions of Michigan as well, seeing this hail risk involved as well. Some of these cells will have updraft helicity with them. You can see the little markers here. That is a rotating supercell, which, if it's able to continue to develop there, we'll continue to have more impacts like this. But all of these will be hail producers based on just the explosive nature and the elevated convection. We could have some pretty big hail in portions of Chicagoland and Chicago proper even, as well as some of these south suburbs down here with that higher tornado threat if those cells are able to stay more discrete. After that, storms should kind of congeal. Maybe some more hail producers in the south, more in central Illinois and things like that. But we don't really see a large wind event as we typically do here in Illinois. I like to look at some of the other cams as well. Ooh, that would be. Let's look at the WRF ARW, and we'll see how this one compares to our HER model. Because again, oftentimes on College DuPage weather, I only have access to the NAM Nest and the HRRR, and we're going to take advantage of having more access to different models here now. Here we don't really see as much of that warm frontal convection. The ARW, this is probably a supercell out here, but the ARW really doesn't develop too many storms. Maybe some more hail producers up here. Overall, not as impressive of an event being shown by this model here. A lot of these other models are more experimental, but I didn't want to show how different cams are looking at this setup. NAM 3K is NAM Nest, as we usually call it, is still coming in, so we're going to use our 12Z run for today. And notice how this one works. As a preface, the NAM Nest loves to develop a lot of little showers all over the place, and this is pretty constant as the birds in the background freak out. It's a pretty constant occurrence, so don't be super dismayed by little blips like that. Again, here you can see our warm front coming in with that warm frontal rain, at least what's trying to develop, and you can see another case of storm initiation out here, basically with that warm front over central Illinois right around 5 p.m. This is probably going to be our best bet for a discrete supercell. You can even, wow, this is pulled a PDS tornado. That's impressive. Either way here, again, another well-curved photograph, fairly streamlined. Apologies for a bad pen drawing there. Good surface-based LCLs. This is going to be pretty conducive environment out here for more tornadic supercells, as we said earlier. With more updraft helicity as these storms basically move to the due east. The NAM Nest does not seem to really develop too many other cells. It seems to form them a lot further north up here in Wisconsin, which, based on our current outlook, doesn't appear to really be in this area of interest as much. So this might be something to consider if you're living in more of a Wisconsin region. You might have a smaller or another region of possible hail production up there, just depending on how this event shapes with time. This is the most recent SPC outlook, but you never really know. If the NAM Nest solution does come to fruition, we might see more of that hail reserved for a region of Wisconsin instead of Chicagoland. But with time, the NAM Nest doesn't really develop too many other major storms, apart from possibly a squall here, maybe some embedded cells. Let's actually take a sounding out here, because I'm curious about that. this environment, possibly some embedded cells. This looks to be convectively enhanced, however. Let me try to get a better spot. Not super great, but either way, we do have some of this pretty nice low-level shear. 850 millibars winds should be kind of cranking here at this point, which will be leading to some stronger possible mesocyclones in the flow if they are able to develop. I think the main things to keep in mind, though, for storm coverage are going to be central Illinois will be a region of discrete convection if it is able to fire. An elevated mixed layer could be too strong. Also, real quick, I do want to mention this is the 850 millibar winds. Oftentimes, when you see stronger winds here, that is going to lead to better low-level cyclones, which is more conducive for tornado development. This is not the only thing that produces tornadoes, but if we imagine our storms developing, basically a line going on right here this time, you do have a good low-level jet to help produce some of those mesocyclones as the storms come through later at night, even right here as well. Very strong low-level jet with the line would be right here at the time, which could produce some cells if they're able to stay more perpendicular to the flow. What's the satellite? Oops. But yeah, the main thing I wanted to really mention was just the main cells that will possibly be produced. Let me go back to 8. Whoa, wrong model run. 18Z here, and we'll just go back to our reflectivity to show what I'm talking about. Just it's a nice open map. Basically, the area I'd be watching out for most for discrete tornado development is going to be right in this vicinity here. Regions of kind of, it's really tough to put an actual label on this, but this area I'm outlining right here. I would be most concerned about discrete development in this region. Your warm front is going to be in a good position. Storms will basically form right to the east and continue to ride along it, and won't be too clustered. You'll have enough development to produce some small cells. Basically right in that region of interest is where I will be paying most close attention to. If you're looking for a hail risk, which I'm going to outline in yellow, you're going to want to be in basically a region right in here. Possibly a little bit of an extension here as well, proportions of Michigan, closer to that boundary as well. Something like that, basically, is where I would outline my risks if I were to. My main concern for tornadoes is going to be in that area in pink, but also you're going to have supercellular characteristics to a lot of these storms. These could drop tornadoes if they're able to become more surface-based, or if you have a line with a spin-up involved as well. But I'm going to be paying close attention to this region in particular. It seems to be the best environment for supercells, and especially tornadic ones that are able to stay low to the ground and be more discreet. So that's about it for this update. If there are any other important updates, I will most likely have a channel post out about that. Again, for more information on this, please do pay attention to the Storm Prediction Center. I am still a university student, so that means I still have more to learn. But I do want to get a little bit more involved in where I believe our highest tornado and hail possibilities are in the future. Just kind of practicing my own outlines for that as well. But if you do have more questions, again, you can always feel free to read the descriptions here that they give in SBC, and just check the outlooks. Again, these are a little bit more confusing. There is more information on them. These are different from last year, so that's something to keep in mind. But yeah, if you have any other comments or concerns, questions, please leave them in the comments. I'm going to be happy to answer. I'll hopefully have a channel post out about this as well, just concerning how this gets updated on the day of the event. So that's all I have for this video. A little bit more of a lengthy one, maybe a little more in depth, but there are some concerns I have with this event. It could really become a pretty big one for an early season March event in Illinois if storms are able to really get going pretty quickly there in central Illinois. So with that, that's all I have for this video. I thank you all for watching, and I'll see you all next time.